In this video, we're going to continue the investigation we did in the last video, where we were looking at a circle with an inscribed angle and a central angle that both inscribe the same arc. And I asked you in the last video to come up with a conjecture about the relative size of those two angles. If you haven't done that yet, go back and do it, because I want you to feel a little bit of that excitement about being a mathematician and coming up with these notions and then proving them yourselves instead of just reading it in a book that somebody wrote 500 years ago. We can do that. So as I say, this is your last chance. Go back to the last video and do some playing around with it if you haven't done that yet. All right, those of you who are left, the conjecture that I hope you came up with is that the measure of the inscribed angle was always half the measurement of the measure of the central angle. And that was true no matter how we swung that point D around the circle. It kept on being the same size. That's pretty cool. I'm a little surprised by that, and I've got a couple degrees. So remember, though, what we've come up with so far is only a conjecture. We're going to need a proof if we need to establish that as an actual fact for all circles. So let's go back to GeoGebra, and I want to come up with a proof of a slightly easier point. So you'll notice here that I've got the circle with A, B, and C. I don't have D yet at the moment, but what I'm going to do is I'm going to create a line that connects A and C. And once again, I want you doing the same thing on your GeoGebra. You should come up with a screen that looks like mine, because you're going to be doing some playing again to come up with more of these ideas yourself. And then I'm going to add a point here where that line crosses the circle. So I've got this line segment going from C to D. What's that called now? What's our vocabulary word for that? That's a diameter going from C to D, because we've got it on that line segment that goes through A, which is the center of the circle. All right, so now I just created those two angles again. And just to see a little fun, an extra fun tool you can do, I can click on Show Hide Object, and I can click on this line outside the circle. And then when I go back to move, boom, it's gone. So it makes our diagram a little cleaner. I can also right click on my labels and move them around a little bit so that they get out of the way of the diagram a little bit. If I ever wanted to make this pretty and print it out on a piece of paper. And the last thing that I'm going to do is I'm going to create angle measurements for all four angles in this diagram. I've got my central angle and my inscribed angle. Can you see the other two angles in this diagram? Well, because we made this very forced choice that CD is a diameter now we've got this triangle. ABD is a triangle. So I've got an angle here at A, and I've got an angle here at B. So I want to measure all four of those angles. So I'm going to click on Measure Angle, and I'll click on BAC. So that's the measure of that angle. I'm going to click on BDA. And then I'm also going to click on DBA. You should do this in the same order. And the reason for that is that the angles that they're coming up with here, they're naming this with the first four letters of the Greek alphabet. Remember how I liked using theta as a variable for angles when we were doing trigonometry? Mathematicians in general, when we're doing geometry, we like using Greek letters for angles. And so the four angles we have here are the first four letters of the Greek alphabet. So this is an alpha. Looks like a lowercase a, but this is a little bit curved here. This is a beta. Looks like a B with a tail on the bottom of it. This is a gamma. Doesn't really look like anything. And this is a delta, lowercase delta. All right, so once again, what I want you to do is I want you to make a diagram like this with your alpha, beta, gamma, delta, and then move these points around and see if you can come up with relationships between the different angles. You know, that maybe one angle is, well, we already know that this angle is twice as big as this angle. There might be other kinds of things. Maybe if two angles add together, they add together to be a certain special number. Maybe if three of the things add together, they're going to have a special value. A lot of these things are going to be observations that we made throughout the course of the year. So some of these angle measurements are not going to be a big surprise to you. Others of them, it might take a little bit of doing for you to understand why it's set up the way it is. But all of the facts that you're going to come up with, and there are, let's see, one, two, three. I'd say there are about three simple facts that you should be able to pick out, in addition to the one conjecture that we've thought of already. And those three more basic facts are going to be the foundation of the proof that we're going to put together in order to prove that the size of the central angle is double the size of the inscribed angle. So keep on working on that, through that worksheet, coming up with those extra three relationships that you see between those angles, and we'll see where that leads us.